All right. Welcome, everybody. Thank you for coming to my talk. Brief introduction about myself. I'm Alessandro Pereno, Sandro for short. Save yourself a few milliseconds if you want. I represent SurrealDB, and I'm running the solutions engineering team. And if you guys haven't heard about SurrealDB, it's a multi-model database, and I'll get a little bit into that in the future in this presentation. But I think a lot of you guys are here to hear about this recommendation engine. I'll give you a background in why this was built and through the whole course of how they built it and what came together to make this thing work at scale. But first I want to have some questions for the crew here. How many folks here have, let's say, an ad tech or marketing tech background? Because we're talking about, okay, handful. How many people have a data, whether it's database, data science? Handful. All right, and how many people came to North Carolina for some chopped barbecue? Oh, there we go, one. That's some good stuff, right? All right. So, recommendation engines. One of the challenges, I think, I'm going to use the sneaker thing because everyone remembers that like Nike sneaker that follows them around. But at the end of the day, what we're really talking about is a recommendation engine that, does okay. You put that thing in there, it's going to be somebody else bought something like this, and it's all right. But people want to do better. And the question is, what do you need to do? Well, let's talk about AI. Of course, AI, LLMs, blah, 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 right? But, this is what they needed, right? At the end of the day, they needed a better experience. They wanted to make happier customers. The way you make happier customers is, trying to get sure that you're solving these challenges. We have, and by the way, the fonts are very small. It's very dark on here. So you need to increase your revenue, basically, and that's where you're going to get through all this stuff is by making your customers happy, making sure they don't churn, making sure everything's relevant. And that's really, really important to do. So if you're going to try to do just yet another A/B test, if that's a marketing approach, that doesn't scale. I mean, that's a really point solution. It's not customized. And the more data that you have around this, you're going to have more opportunities. Which brings you to the notion of what is the personalization? What is a luxury brand really trying to do? It's about hyper-personalization. It's not just about, hey, this is the relevant thing that someone else bought, but it's got to be bespoke. It's got to feel natural. It's the reason why someone is interested in luxury in the first place. So I don't know anyone has a significant other who has very expensive tastes, and you realize that you can't just buy yet the same thing that was on the magazine. It's got to be slightly different, but it's got to make sense to them. So the reality here, it's not just about the product, and it's not just about the person. It's about all the contextual relationships that they have and similar people have, and that's a really hard problem to solve. If we're going to just talk about like an algorithm that magically does it, you're going to fail. I mean, what we really need is something more expansive, and this is where the layers of AI and flavors of LLMs, all these things become actually relevant today. However, we have to remember that this has to also be consistent. So it's one thing if you have your little black box and it's great at doing this thing and it's only plugged up because it only responds in a speed that makes sense to one channel. We have to make sure that this is something that's rinse and repeatable across all the different touch points of a customer's journey. Now, moving forward, we want to, why does this get hard, right? So just throw an LLM. I mean, I touched on this a little bit, but a lot of these solutions out there, especially the turnkey ones, they expect everything to be in a single table, right? They want to have the proverbial spreadsheet, because why? Because a lot of these analytics solutions, they'll call them analytics, even though it's really, there's some powerful AI algorithms. They're coming from a different time. Like these are just algorithms that have been out there for a long time, and they're not really advanced enough in order to take advantage of some of the other cool technologies out there. Another thing is it's a schema that's fixed. No one's really going to be used, schemaless design and all kinds of stuff, and God forbid we even start talking about graphs. So I'll talk about graphs in a little bit later, but like graphs become really powerful when you're talking about a recommendation engine, mostly because a lot of the relationships that we're talking about, the contextual stuff, but also even the product hierarchy. That's really critical to what this stuff looks like in practice. And And the result of that is, if you make a schema change and it has downstream effects on lots of different teams, or, a lot of this means that either your dev is really slow. So if you have a really brilliant insight of how to tweak that recommendation engine, that means it's a slow, it's a lack of agility. So it's going to take your dev cycles even longer to get that new feature into production. B, you might just choose not to do it because it's too much pain and your recommendation is good enough, right? Like that good enough trade-off when it comes to engineering resources. Unfortunately, we all know, you deprioritize something until it just doesn't exist anymore. So what do you need? Well, there's a few things. All right, who here has been on something about a RAG at least once today? Or no one knows what a RAG is, right? Yeah, of course, right? So we're actually not even talking about RAGs, but I think what we're going to be talking about a little bit is embeddings. So embeddings 101, do we need to go through that? I'll do a little bit of embedding talk. For lack of a better concept, is any piece of data, text, binary, whatever, and you want to compare stuff to other stuff, you use an embedding algorithm in order to turn it into a vector. And that vector in vector space can be compared to other vectors, and that's how you get a semantic understanding of two or multiple different things that are all related to each other. That becomes very powerful for what we're going to be talking about. RAG is probably the use case that most people know. However, it's also really important in a lot of other ways too. Next part that we really need to talk about, I briefly mentioned the schemaless. I should say it's not just schemaless. You also need a notion of having schemaless with schemaful. And a few other flavors of what we're going to get into here, because it's the combination of not just throw it in there, great, and fetch. Throw and fetch is not very useful when you're looking at whether it's analytic workloads or you're trying to do things with, as I said, vector search, and more especially graphs. Now, graphs are like a super cool thing that, in my opinion, are underutilized, I think, because a lot of the tooling around graphs are really hard. And at the end of the day, why are graphs really interesting in retail? So let me ask a question. If I were to say a perfume bottle, what do you guys would consider a perfume bottle? Anyone? Is it accessory, beauty product, liquid? So many different ways to describe these things. It could be called tags or whatever. However, there's also different things about the properties within these. And I'll go into a little bit more details, but the nature of how we represent data as a human, it's very easy to forget that a lot of these things are how they're connected as well. And context matters, and context can be reflected in graphs really well. And the last bit, well, actually, there's two more things. Before that, we got to talk about scale. If you're an actual retailer of consequence, you're going to have more than a few customers at a time. So you have to make sure that this thing scales. But you also have to worry about seasonality. So when I say scale, I don't like to just talk about scale up. It's really easy to make a very big anything, especially in a database. Nowadays you have lots of ways to distribute and balance and get lots of big nodes out there. That's really easy to do. And maybe not so easy, because sharding is always a fun thing to discuss with people. However, I will come back and say it's the scaling down. Black Friday happens once a year, and maybe you have multiple Black Fridays. But when Black Friday is done, you don't want to have to carry the burden of that massive thing throughout all of your day. I mean, we're going back essentially to the days of, the appliances in the corner that you got to call up your rep to get another $1 million worth of storage attached. That is no longer what you should live with, and quite frankly, you have to also be able to live with the fact that you don't always know how big Black Friday is going to be, right? So those are the things that I think we need to be mindful of, and when you bring them all together, it's also got to be done real time. So I know real time is a loaded word, because at the end of the day, everyone's definition of real time is a little bit different. If I'm coming from an OLAP perspective, once upon a time, I worked for a columnar database. For us, getting a customer's query down from something that used to run in an hour down to 30 seconds, it's like, woohoo, 30 seconds, that's massive improvement. But yeah, but in front of a UX, a 30-second spinning thing is something that was not sold, right? So real time has to be that type of real time on one side, but also real time making sure that the data getting into the decision matrix. So if I'm looking at this proverbial shoe and I like this shoe, but I bought the shoe already, I don't necessarily want to see another shoe. I just bought my shoes. Show me something else. So that's got to happen real time. And that's what I'm talking about, real time. Cool. So what is SerialDB? Show of hands, how many came by the booth or know what we are yet? Oh, thank you, thank you. You liked our swag? It's nice? Yeah, I know. Pink and purple, those are our colors. I won't take you on the full journey. Please come by and talk to us at the booth and we can go into more details. But what I will say, at the heart of SerialDB, we decided, and I should say our founder decided, to write a database from scratch to solve multi-model. Why multi-model? Every time he deployed yet a new app or yet a new project into production, he got sick and tired of carrying about 5 databases with him, making sure data was consistent across 5 different technologies, making sure that the languages involved, the same query had to be potentially written in 5 different databases or cache warmed or whatever, so you express the same business logic multiple times in multiple different flavors. It was quite annoying. So annoying, in fact, he decided to write his own database. I do not recommend that for most people. In fact, if he asked me at the time, I'd be like, you're crazy. But he did it, and it worked. It worked so well that people got super interested in it, but it wouldn't scale. So he went back to the well and he asked, raised some money, got a team together, and they rebuilt it in Rust. So this is why we are a Serial database, because it actually delivers on the promises of a multi-model database, and it's actually performant. So I'll encourage you to download it and play with it on your own, and we can talk about that later. But first, a lot of people don't understand what multi-model is. Some people, especially in the data science belt, hear multimodal, which to them means video and text and audio. We're not talking about that. Multi-model, and I hope we can come up with a better way to make this more clear, but at the end of the day, there's multiple flavors of databases. Some people don't even consider them databases, but we do. So a relational database, that's the one everyone knows and loves. I don't care if everyone knows some flavor of SQL in the world, or if you don't, you're probably at the wrong conference. Graph. Graph is super interesting, as I mentioned, for multiple reasons. But the challenge about graph, it's not natural to SQL. And we'll get in a little bit what that looks like with Serial as part of this. But we also have to talk about embeddings, and embeddings can be stored in a vector database. Vector databases are very powerful, but they're usually very point solutions in a lot of the things that we know out there. It's not so fun to move this stuff back and forth. And the number of dimensions in an array is important in some use cases, but for a lot of them, you can get away with some really powerful stuff without going super whole hog all on index. And then we talk about time series. Time series is really about anomaly detection in my mind. And we can keep going. We got geo. A lot of people want to do lots of interesting calculations on longitude and latitude, and how things are related on arcs and all that stuff. I'm not a geo guy, but you can follow up with one of our guys and go in deep there, and we're not talking about that. But yeah, the thing that I think a lot of people come back to is this unstructured, the document store. A lot of people start with that, and they try to connect the dots and make it work more relational and vice versa. This is where I think we have a lot of friction within our collective data ecosystems, and it's reflected as just, this doesn't look the same, and I can't do what I want to do. Well, we posit you can. And with all these things together, and I didn't even go through them all, you're going to find a way to get really cool stuff out the door. And I will say that one of the reasons why a lot of people are using Serial in general, but it's also important for this particular project that we'll talk about, is the connectivity. So SDKs, SDKs, SDKs. Make sure that you can develop on the platform you need. It can't just be a driver anymore. It's got to be a flexible way to meet people where they're at. That means modern languages. That means safe languages. That means all the places where you need to be, whether it's a data scientist or someone going to production or a Java shop that needs to make sure that this just works in their, in their Java environment, right? So let's hear. Why are we here? SerilDB. Well, first of all, I mentioned it was Rust, right? So built on Rust means that there's no concurrency challenges, that's a wordful, for writes versus reads. So we make sure that this thing will be ACID compliant at scale. And that's just obviously look at the code, but yeah, you got to trust me on this until you read all the code. It's a lot. It's scalability. So it's not just about scaling up. It's not just about getting bigger. It's also about scaling out. And it's also about scaling for concurrency. So when I think of scale, I think of it as a three-legged stool. You have how many users are hitting the thing, your QPS, whatever metric you want to think about there. Maybe on point queries, maybe on simple queries, or maybe it's on writes. You also have to think about, well, what are the other two stools? Well, you might have a lot of data, you might have a little data. And those things are not necessarily correlated to each other. And then lastly, you also have the notion of how complex this is. Do I actually, through all the machinations I can possibly imagine, have to do a full table scan on a large amount of data? So do you need node sizes that are massive? Well, we bring this all together in such a way that this is all tuning that you can do in all three dimensions. And it's really important that you can also scale it back, as I was mentioning earlier. And now we also know that AI is becoming the thing. And I know I don't want to say AI over and over, but it's really important that we understand that embeddings are going to be part of all of our development cycles probably moving forward. I don't care what space you're in. You probably have a use for embeddings and vectors. Maybe not the super, as I said, let's call it the very niche reasons to go for something very, very specific and powerful. And I don't want to discourage someone who has one of those use cases from trying to shoehorn all their stuff into us, but it's something to consider. And then obviously the flexibility of development, right? So we have a very flexible version of SQL, which we can't say is ANSI SQL because we actually support Graph and a few other things that can only be expressed in ways that kind of break ANSI SQL. But most importantly, we're built in Rust. So Rust being our native language also means that it's really cool and fun to develop in as well if you're a Rust developer. Pardon, let me take a little sip of water. I'm getting parched. All right, so back to our use case. What does this look like? If this microphone could go, I'd usually walk over here and point to this. So imagine I can actually have a laser pointer or something here. All right, so looking at this is a very simple diagram. I didn't want to overly complicate it. But our user, in this case, interacting with the recommendation engine, and by interacting, I'll say this could be mobile, this could be an email, this could be within the website. It's a point of, when I say UX, it doesn't actually have to be a physical UX, it's an interaction with the user. They're working basically with, I don't want to say RAG, but something similar to that with prompt templates, et cetera, that might be saying like, hey, I need to find some recommendations on this user. And in that context window, we're going to bring in a bunch of data. But before we talk about that, all the other interactions within the ecosystem of the retailer are also being logged and recorded and streamed into the database at the same time. So I'm breaking it down in three different kind of categories. So we have the actual product catalog, so the full catalog of what could be purchased. We have the prompt memory, because obviously anyone who's built any of this stuff, you have to keep a running record of all the subsequent follow-ups that you have with the LLM in order to get relevant information back if it takes multiple hops. And then you have the contextual facts. So I won't be exhaustive here, but I'll give you some examples. It could be interactions on the app or the website. How long did they linger on something? Did they click on something? What reviews did they write? All the things that you can imagine might be interesting, but there's no way that you could actually build an algorithm as a human that would always be quote unquote correct are relevant. I mean, we can outthink these things. LLMs are brilliant at putting this stuff together. So simple prompt, and this isn't the prompt, but like, hey, recommend me something for this person based upon all this stuff, right? Like that's kind of what this thing is doing, but at scale. And don't quote me on that, please. But that's kind of what it looks like. So you're putting all this together. And now we got to talk about what this looks like. So the two legs that I'm really interested in sharing here is vector search, because vector search is really important. Talked about embeddings. This is how Surreal kind of deals with vector search. And I don't know if you can see the top left. Those are basically things that you would see in the predicate of how we go after vector search. So 3 different modalities basically of how to find things that are close to each other, and obviously different parameters involved. And underneath you have all the types of distance calculations that you could consider and things like that. So with all these simple page, you can reflect a lot of power, and quite frankly I would say you don't need much more. Sure, you can do some other things, but we can talk about those in offline. And this is what it kind of looks like for something here. So so you can see this is my silly example, but find me some sneakers that scream cool and put the little scream thing down there, you know, any references to, yeah. So this is what it kind of looks like. So you get this vector back basically, and now you're using the vector. In this case, this is just a brute force looking for 2 levels, 2 distance levels away from the actual vector. And now it's going to return, in this case, excuse me, of the sample and the content around this in a vector store that's just sitting in a normal table. You can have a table of anything, add a column called vector or whatever the hell you want to call it, add your embeddings, and there you go. So, graph. This is how we think about graph. I kind of put it this way because a lot of people, if anyone's done graph, and again, how many people SQL versus graph? SQL heads, graph heads? Both. All right, so you guys know. It's very different than SQL. It's kind of annoying for me. I come from an old school SQL background. Like I'm very much more used to seeing what's on the right. It's easier for me. And I might be odd in here, but for me, it makes a lot more sense. And the thing that's really special about Surreal is that we boil it down to like a very simple operator of that little arrow thing. And the arrow, in this case, they can point in both directions, one way or the other. It's really about how you point from edges to nodes, and that's how you can express that. So I have a very simple way to demo this. Is in a simple way is that like I kind of build a retargeting query as a query, like one line of SQL, and it does everything that other people bought of the thing that I put in there, and you get my recursive thing, and it just goes edge to node, edge to node, edge to node, and it's very simple. It's really easy to understand. So this is why we're feeling like a lot of this can be simplified, but it's also about having the same data in the same place. So 2 reasons why it's important to talk about graph in this way. But in this case, graph becomes super important in this retail use case because if anyone's ever done any kind of inventory, it's difficult. It's really hard. It's very hard to compare the same hierarchy of a t-shirt to that perfume bottle. We can say, what is the size of, a perfume bottle? It's 30 milliliters or 50 milliliters. What's the size of a t-shirt? Small, medium, large, right? Like those are not the same thing, but they're all properties. You can also just shove them in a schemaless way, but then you lose a lot of the contextual relevance of why these are connected. Also, again, that perfume bottle could be in beauty, it could be in accessories, should be both. You shouldn't have to force these things. And when you add all these layers of complexity, it's really hard to do this in a relational way. And if you do it in a pure schemaless way, it's up to you at the application layer to actually know where all this stuff is kind of sitting. It's not that very easy to like really piece this apart unless your business logic is also represented multiple times. And this is just a quick way to show that in this use case, they were actually using option group and variant as their terminology internally of how to express these types of different parameters that might be around any particular product. So yeah, underneath there, it would be a schemaless design that but you can think about how this works together within a graph and how these things are related. So, excuse me, another water break. Scale. So when I first saw Surreal and I met the founders, the reason why I got personally very excited, because coming from a big data columnar background, I saw what these guys were building from an architectural perspective, and it wowed me. Basically, this is a simplified way that I like to think about the architecture, and bear with me here, because I'll say that this particular use case isn't using the cloud, so that last leg on here of the persistent object storage isn't necessary, but it's one that I just like to show the art of the possible here. So underneath the covers, you have a distributed KV store. Again, this can scale out, scale down. It is basically the size of your data. That's what we're scaling back and forth here, right? Now, the SurrealDB nodes that I'm showing here, that's your computational layer. That's where you're doing your aggregates. That's where you're doing, all the logic that you would have in the SQL statement that's being fetched efficiently from the KV store. And there's a few reasons why this is very efficient. One is, well, the KV stores in general are good at what they do in terms of distributing and being able to return stuff really fast. But what we're also doing is, on the object side, we're writing our IDs as objects. So the ID space itself can be efficiently pruned, because you can actually query within the ID space and not actually even have a where statement if you don't need to. So we're kind of pruning before the pruning. I can show you more in detail, but if you follow the logic there, we're making sure that you can get the data from the KV store to a node very fast, because we're only pulling back the data that's really relevant to your query. And the nice thing about this, since it's ACID compliant, and the concurrency challenge can be mitigated by having multiple different nodes on the computational side, you can have an application that's a heavy writer. So you have lots of little write nodes, because all it's doing is just dumping some data, some unstructured data. Great. Boom, 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 boom. At the same token, you can also have an analytics workload that's running on some monster 64 CPU thing with lots of memory, because, again, it needs to do a lot of table scans. And for concurrency, you might have two of them because you have two data science teams. But you can throw them away at the end of the day. You can throw them away within an hour. And that's where the power of this architecture comes into play, combining the power of all the types of things I'd like to do with the queries I'd love to do. So I'd love to try vector and love to try graph, but I want to do it in such a way that I have access to the same data across the same platforms, and I'm not pissing off somebody by, making sure production stays up. So this is the whole power of putting these things together. Now, putting it all together, this is what happened in this use case. So that whole diagram that was put in place with SurrealDB as the underlying data store, this customer has rolled this out right now to 4 million customers monthly in terms of recommendations, and that represents 1.5 million interactions with these users every week. And anyone who's a marketer here will appreciate this number. 3x increase in conversion rates when using this engine versus the old one. And this is going, I believe, somewhere a little bit under 1.5% to just under 4%, which is a pretty big number and a pretty big jump just by changing out a tech stack. And right now I should say, this thing has been up and running and it hasn't fallen over once, which is another nice thing, especially as a proof point for a young and upcoming database. Then the next step is, this is also just right now on their mobile and email. They're going to be rolling this out right now to all the interactions across all the recommendations across all the entire shop, which is exciting, and I'm looking forward for how that goes. The other things that we can talk about, and this art of the possible, but like at the end of the day, you can do so much when you can start comparing these like different modalities. So it could be about adding other things to the contextual notion of product and people. So body type or whatever you want to say. You can imagine all the things that you can do. But the nice thing about this, all that thing going back to the schema changes and the agility that you have, you don't have to go back and say like, hey, I need to add another column, or I need to do all these things. And as a result of that, well, my whole model's changed and I have to redo all this stuff. It is now just, I collect more data. The thing, let's make sure it doesn't fall over, create bias and all the stuff that you would normally have to do from an AI perspective. But it's a much more agile, much more friendly way to engage your customer in new ways that delight them, don't piss them off, and don't take forever. So you're always able to iterate. So I'm going to stop now. I talked a lot and I need another sip of water. So I'm going to open the floor to questions.